depth of education, let us continue with detection of cations using sodium hydroxide solution. So we had a simple summary of our work in this case, how these different cations respond to sodium hydroxide solution when added just a few drops, and when the number of drops in this case is in excess, or when the reagent solution is in excess. Then we came down and also looked at the chemistry behind each of these reactions here, which leads to these particular observations. So we said that firstly, when we have added a few drops, we are able to get some precipitate with some of the cations. And we say that every single precipitate, be it white or blue or green or brown, is an insoluble hydroxide of that particular cation, formed as a result of the combination of the cation with the hydroxide ion of sodium hydroxide. So we got them. And this one is with the exception of ammonium ion that gives us no observable change. It doesn't mean that say the hydroxide is not formed. No. The hydroxide, ammonium hydroxide, is also formed. Only that it is a soluble hydroxide. It is an alkali. An alkali is a soluble base. All these ones are bases, but they are insoluble in water. That's why they are precipitated as white, blue, green, or brown precipitates. But with ammonium ion, the ammonium hydroxide which has been formed is not precipitated because it is a soluble base, what we call an alkali. Now, in this session, we are going to look at some of these precipitates that are soluble in excess sodium hydroxide solution. So, allow me remove the ones which are not soluble, because there is no any further reaction equation as pertains to them, as pertains to the hydroxides that they are formed. They cannot dissolve in excess sodium hydroxide solution. So let us simply put them aside first, but we should not be able to forget them. I believe that the candidates in this case have seen that the number of hydroxide ions that each cation combines with is equal to the number of positive charges that the cation contains, like calcium ion with 2 positive charges combines with 2 hydroxide ions to form calcium hydroxide. Ammonium ion with 1 positive charge also combines with only 1 hydroxide ion to form ammonium hydroxide. Aluminum ion with 3 positive charges combines with 3 hydroxide ions to form aluminum hydroxide. So for some of these cations here, that forms precipitates that do not give us any other observable change in excess. We are firstly going to put them aside, and then we see the reactions these ones undergoes, the one that gives us other observations when we have added excess reagent of sodium hydroxide solution. So we can see clearly from here that ZAP, zinc ion, aluminum ion, and lead ion gives us a white precipitate, and in excess there is a different observation here that we get, the precipitates are soluble in excess to form colorless solutions. And then with ammonium ion, there is no observable change, but then in excess we are able to get ammonia gas, which is presented as we can see from here on heating. So we are going to zero on these ones here and see the reactions that they undergo later on. So let us see these ones here. Allow me to use some arrows, and then we try to split them well. So let us go to zinc ion. We say that it forms a white precipitate, that is zinc hydroxide. Then in excess, the precipitates dissolve to form a colorless solution. In this case, for zinc hydroxide, the white precipitate formed. So in this case, the zinc, maybe let me use blue to show that they are now different. It is now in excess. Let me use blue to give us a clear distinction in this case. So the zinc hydroxide. Since it is formed when we add just a few drops of sodium hydroxide solution, when we continue adding the sodium hydroxide, we add now in excess. It dissolves by so combining with the excess hydroxide, ion of sodium hydroxide, to form a colorless solution which contains a complex ion in this case, which is called, let me first write the name down, the formula down. So this is what we get. It is a soluble complex ion and it is called tetra 4 hydroxyl groups, in this case in hydroxide, tetrahydroxy zincate ion. It is a negative ion, so it is not zinc ion but zincate ion, a negative complex ion of this zinc. So tetrahydroxy zincate ion. Let us go to aluminium hydroxide, the white crystal formed in this case by aluminium ion. So in excess also, the aluminium hydroxide which has been formed, will combine with it. This one, let us balance it by multiplying the hydroxide ion by 2, because here there are 4. These 2 plus these 2 gives us 4. Plus the hydroxide ion in this case. We are also able to get our tetrahydroxy, not aluminium this time, but we have aluminate ion, OH 4 minus. So it is only gaining 1 hydroxide ion to make 4 tetrahydroxy aluminate ion. Others calls it just aluminate ion, but it's tetrahydroxy aluminate ion. It is in the colorless solution which has been formed. Soluble in excess to form a colorless solution. We also have the lead 2 hydroxide formed in this case. So this lead 2 hydroxide also will combine with the hydroxide ions, aqueous, to produce our PbOH 4 2 minus, aqueous, the colorless solution. This one is having tetrahydroxy plumbate ion. You can see the chemical symbol of lead is capital P small b, that's plumber. So if it is the negative ion of lead in a complex ion, it will be plumbate ion, the tetrahydroxy plumbate ion. And then finally, we have this ammonium hydroxide here, which is not formed as a precipitate. The fact that it is a soluble hydroxide, it is an alkali. It is formed, yes, the colorless solution in the mixture is ammonium hydroxide, and then on heating, the ammonium hydroxide will also be decomposed by heat, and what we get is the ammonia gas, and we also get water. This one is a forced decomposition by heat. It is not just spontaneous. The ammonium hydroxide is heated and then there is thermal decomposition, and the ammonium hydroxide decomposes into ammonia and water. So that's why we are able to get a colorless gas with a choking, irritating smell and turns moist red litmus paper to blue on heating. The heating does the decomposition of the ammonium hydroxide into ammonia and water. So these are the reactions which are involved in this case when we add excess sodium hydroxide solution to solutions of zinc iron, aluminum iron and lead 2 iron, and then also we have included ammonium ion. So these first three cations here forms a white precipitate which is soluble in excess to form a colorless solution. The formation of the white precipitate is all about precipitation of the insoluble hydroxides as for the first three. Then in excess we can see that they react with excess sodium hydroxide solution and produce colorless solutions, in this case which contains these complex ions. There is one important property of zinc, aluminum and lead in this case, that when we add a few drops of sodium hydroxide solution, they first form their hydroxides in this case which are insoluble. Now all these hydroxides here, let me put them together. Zinc hydroxide, aluminum hydroxide, lead 2 hydroxide, which are all formed as, in this case, white precipitates. They are having one important property, that they are amphoteric. They are amphoteric hydroxides. They are amphoteric in the sense that they react with both acids and alkalis. So they can react with an acid since they are bases to form salts and water only in a neutralization process. Then they can also react with the alkalis as we have seen. So in this case they react with excess sodium hydroxide solution. When they have already been precipitated or formed, they react with sodium hydroxide solution since they are amphoteric in nature, and they form their respective solutions containing these complex ions here as we have seen. So we should know that these are the reactions when we have added just a few drops. Then in excess we are able to get the colorless solutions for the first three cations. Meanwhile, for in this case the ammonium hydroxide, which is formed in this case as a solution but not as a precipitate, when you go ahead and you heat, then you get this. So the heating decomposes the ammonium hydroxide into ammonia and water. That's why we said that when you heat, you need to test for ammonia. When you use sodium hydroxide solution and you get no observable change on heating, please, you need to be able to test for ammonia. And also your nose should be able to smell the gas. That choking, irritating smell, you should be able to get it. So the zinc hydroxide, aluminum hydroxide, lead 2 hydroxide formed as white precipitates, as we have said, they are able to react with the excess sodium hydroxide solution. The fact that they have that amphoteric nature, so they are the amphoteric hydroxides. So they react with excess sodium hydroxide solution to form their respective complex ions, as we have seen from here in colorless solutions. So even ordinarily when they ask you for the zinc, for the amphoteric oxides, they are the ZAP oxides, zinc, aluminum and lead. Even their hydroxides are all what? Amphoteric. So don't forget that the amphoteric oxides are the oxides of zinc, aluminum and lead. As I have said that we may call them the ZAP oxides or ZAP hydroxides. They are all what? Amphoteric. They react with both acids and alkalis. And in this case, that's why we call them the amphoteric oxides or amphoteric hydroxides. So these amphoteric hydroxides formed, they have clearly shown us that by reacting with excess sodium hydroxide solutions to form complex ions, to form colorless solutions containing complex ions. TEP Talks Education, thank you for watching.